In this video, we will practice finding the component form and magnitude of a vector given the initial point and the terminal point of the vector. First of all, let's remember how component form works. A vector is a quantity that has a magnitude and a direction. So it has some type of a size and it has a direction. So a perfect representation is to use an arrow for that. This arrow doesn't mean it goes forever. It has a beginning and an end. It has an initial point, which would be here, and it has a terminal point, which would be here. Now, as far as component form goes, you can take a vector and break it down into its horizontal component and its vertical component. All right, so imagine that this particular vector goes over 3 and up 4. So the component form for this vector would be 3, 4, and we'd use these brackets that look like less than and greater than signs. Let's say that this is vector v. Let's just call this vector v. Now the magnitude of vector v would be indicated this way. The magnitude is just going to be the length of this vector, which of course we could do the Pythagorean theorem in order to find it, and it would turn out to be the square root of 3 squared plus 4 squared, which would turn out to be 5. Okay, so that's the basic idea. Now, what if instead of being given the horizontal component and the vertical component, what if we are given the coordinates of the initial point and the coordinates of the terminal point? We could figure out the horizontal component by subtracting the x's. So the horizontal component would just be x2 minus x1. That would be the length of this side of the triangle. The vertical component would be y2 minus y1. We could just subtract the y values. So again, if we call this vector v, the component form of vector v would just be x2 minus x1, comma y2 minus y1. All right, it's just the horizontal part and the vertical part, but you could find those numbers by subtracting the x's and subtracting the y's. Now here the order matters. It has to be the terminal point minus the initial point. So for problem number 1, we are asked to find the component form for vector PQ. The P and the Q in this order means that point P is the initial point, and then point Q is the terminal point. Okay, so this is the initial point, and this is the terminal point of this vector. So we should be able to find the component form by subtracting the x's. So we need to do x2 minus x1. Now, I'm hoping that you'll see immediately that if I do 3 minus negative 2, that's going to be 3 plus 2. Okay, this is me doing 3 minus negative 2. All right, but from now on, I'm just going to put plus because we know that minus and negative is positive. All right, so that's x2 minus x1. Now, for the vertical component, it's going to be y2 minus y1. So this is how we can find the component form of vector PQ. So that's going to give us 5, 2. And so that's it for the component form. All right. Now, how about the magnitude? Now, let's find the magnitude. All right, so I'll do that over here. So the magnitude of vector PQ would be written this way. And we will just do the square root of 5 squared plus 2 squared. Okay, so the magnitude of vector PQ is going to equal the square root of 25 plus 4, and that's going to be the square root of 29. All right, so we found the component form and the magnitude. Now let's practice that over and over again. Okay, so RS, let's see what those points are. So the initial point is the point R, which is -2, 5. And then the terminal point is S, which is 2, -8. So if I want to find the component form, I will do x2 minus x1. So again, that's going to be 2 plus 2 because I'm subtracting a negative number, so I add. And then I will have y2 minus y1, so -8 minus 5. Okay, so the component form for vector RS is going to be 4, -13. So that's the component form. Now let's do that magnitude. So the magnitude of vector RS is going to be the square root of 4 squared plus -13 squared. So that's going to be 16 plus 169. So that's going to be the square root of 185, which does not simplify any further. So that's it. So we have the component form and the magnitude of vector RS. All right, for number 3, we're going to work with vector QR. So we need to find out what's Q and what's R. So point Q is the point 3, 4. That is our initial point. And point R is -2, 5. So -2, 5. So if I want to find my component form for vector QR, that's going to be x2 minus x1, so -2 minus 3, and then y2 minus y1, so 5 minus 4. So that's going to be -5, 1. So that is the component form of vector QR. Now let's talk magnitude. So the magnitude of vector QR will be the square root of -5 squared plus 1 squared. So that's 25 plus 1. So that's the square root of 26. Okay, so number 4, we are talking about vector PS. So what's P and what's S? So P is -2, 2. So that's my initial point is -2, 2. And my terminal point is S, which is 2, -8. Okay, so if I want to find my component form, I will do x2 minus x1. So that'll be 2 minus -2, which is 2 plus 2. And then I will do -8 minus 2. So that's going to be 4 comma negative 10. So there's my component form. All right, now let's talk magnitude. That's going to be the square root of 4 squared plus negative 10 squared. So that's going to be the square root of 16 plus 100. So that's going to be the square root of 116. Now this does simplify. 116 is divisible by 4. So I can break this down as 4 times 29. 4, of course, is a perfect square. So when I take the square root of 4, I get 2 outside of the radical. And the 29 has to stay on the inside. So our final answer for the magnitude of vector RS should be 2 radical 29. Number 5, Q to S. Let's see, what's Q? All right, Q is 3, 4, and S is 2, negative 8. Okay. So for component form of vector QS, I will have x minus x, so that's 2 minus 3, and then y2 minus y1, so negative 8 minus 4. So vector QS in component form will be negative 1, comma, negative 12. So that is it for component form. Meanwhile, magnitude. The magnitude of vector QS will be the square root of negative 1 squared plus negative 12 squared. So that's going to be the square root of 1 plus 144. So that's the square root of 145, which cannot be simplified. So this is the magnitude. All right, let's look at number 6, PR. Let's see, what's P and what's R? So P is negative 2, 2, and R is negative 2, 5. So in component form, vector PR is going to equal x2 minus x1. So that's negative 2 plus 2 minus negative is a positive. And then y2 minus y1, so 5 minus 2. Oh, I'm accidentally putting the magnitude symbols on here. Didn't mean to do that. So in component form, that's going to be 0, comma 3. So there is my component form. Now let's do the magnitude. So now I will use my absolute value looking symbols. All right, and this is just going to be, I feel silly using this formula now because 0 squared is just going to be 0. So you really should just be able to look at this and know the answer without going through these motions. All right, but I'm going to go ahead and do it just to show that the system works. no matter what. Okay, so the magnitude is 3. Now, do we need to do all these calculations? No. As soon as we saw that this was 0, 3, there is no horizontal component. There's only a vertical component. So we're talking about a vector that is vertical, that is just straight up, and has a length of 3. So the magnitude, of course, will just be 3. All right, guys, that's going to do it for this video. I will see you on the next video if you're interested in learning how to add and subtract vectors using the two methods, the triangle method and the parallelogram method.